Hi, welcome back to Kodsnack. I'm Fredrik, and today I have dual guests, Lars and Matt. Hey, guys.
Howdy, howdy.
Hello.
So, for listeners who weren't there, I would say that this discussion started during a dinner at the RDEV conference, right?
Pretty much, yes. For me, it started during the speakers' dinner after kallbadhuset and saunas and stuff.
That was the experience.
Because I ended up next to Matt, so Matt Topol. Is that the correct pronunciation?
That is. I applaud you.
I might have heard it a few times during your other stuff. I don't know.
It is rare that people get it correct. So
cool.
I applaud that.
Yeah. I guess the safe kind of computer science nerd thing is to go towards Topol.
Well, that I've heard Topol, I've heard Topal. It's like, yeah, it's a Polish name.
Yeah.
I would expect you guys to be able to get it at least.
A little bit of luck. I make a sport out of having Americans try to pronounce Lars Wikman, which is, it doesn't sound how you would read it in an American accent, let's just say.
No.
Can confirm.
Yeah.
Yeah, but you talked a little bit about Apache Arrow, and I was like, Apache Arrow, haven't heard of that. And it's an Apache project, so it's probably like old, dated in Java, right? Okay, I know he's talking about data, so it might not be that old. Well, there's a lot of old data. Let's see. And as the conversation went on, it was clear that it's about kind of doing efficient things with data, and that you're very, very deep in it and doing a bunch of that work. And since I've fallen completely down a Apache Arrow rabbit hole, which Matt knows very well because he gets DMs from me on LinkedIn where I'm like, hey, does this exist? Is this a thing? Should we be doing this or that? What's this? It's been a real nerd snipe. I wasn't feeling it during that dinner. Then I was like, that's probably good for other people. But then I've piece by piece realized just what I think is the massive potential of it. So maybe you introduce what it actually is, because I think you've practiced that more than I have.
Yep, to give a quick
of this small project called Apache Arrow, that is certainly just one thing.
I mean, Arrow started in 2016-ish, co-created by Wes McKinney, the guy who made Pandas. Arrow itself is it's two things. It defines a format for column-oriented in-memory data representation, and collectively, the variety of implementations of that format are collectively the Arrow project itself, along with various other supporting libraries and usability stuff that comes with it. But at its core, it really is that format, that spec. And the importance there is that you have this identical representation in memory, regardless of what language you're working with. Which means that you can then take that data and pass it between runtimes, between processes, between languages, between systems, without having to perform any kind of serialization or deserialization to pass it around. The actual memory representation, the layout in memory, is the same regardless. And that enables a whole host of optimized performance things, in addition to the fact that the format itself is column-oriented, which makes it extremely performant for the majority of data processing tasks. It takes you're going to take advantage of SIMD and vectorization. Those are the same thing, but you might know them by different names. But it takes advantage of those because of the fact that a lot of the time, when you're performing any kind of analytical processes on data, OLAP, you're going to be working on columns collectively, and therefore by laying them out in memory in one fell swoop contiguous chunk for the column, you can leverage the vectorization because that's required for vectorization, and it's already laid out that way. And then because of the fact that it's laid out identically wherever you go, it allows you to extremely performantly pass data around, whether you're in the same system or you're passing in between runtimes. A great example of that is, let's say you're working with Spark, which is very common, and you have humongous amounts of data, very common. One of the big problems with Spark is getting that data in and out of Spark, because Spark runs in the JVM, and one of the common ways of interacting with it is PySpark. So every time you want to take your data from Python and get it into Spark and out of Spark, you have to serialize and deserialize it to pass it to and from the JVM. Using Arrow, by the way, this is already available. You can already do this. Using Arrow, you can enable an option for Spark and take the Arrow data as is and pass the memory as is to Spark JVM.
Wow.
You pass the pointers. And now it can reference the data right where it was.
The amount of projects that are JVM plus Python in the data space is ludicrous.
Exactly. So you get an enormous benefits because of that, and that's just in that little bit. Then you deal with the fact that you're talking about a distributed system, which means every time you pass that data from one node to another node, you're benefiting from Arrow because you're not paying a serialization cost or a deserialization cost. You're literally just dump the bytes as they are from memory. So that, in a nutshell, and an example, is Arrow. You've got implementations in C++, Python, Java, Go, R, Ruby, Julia, MATLAB, Rust, JavaScript, TypeScript. I know I'm missing a couple in there.
Yeah, well, there will be links.
As an Elixir developer, I can say that Explorer is the way to use Arrow in Elixir currently. And Explorer builds on top of Polars, which is a Rust data frame library. So typically...
Polars is Arrow.
Yeah. I think like Polars adds some API on top of Arrow, right?
Yeah. The underlying memory representation that Polars uses is the Arrow 2 Rust library.
Yeah. Something I'm curious about with Arrow that I haven't dug into is when transforming data. Like many times where you write that Python code, it's because you are doing some transformation or some calculation. I imagine that's where you go from 0 copy to 1 copy, essentially, when you're starting to modify something.
Yeah.
How much of it does actually have to change? Like, is it still a very minimal operation, or does it tend to be a bigger copy?
So, Arrow in itself is intended to be an immutable array. When you create an Arrow array, it is intended to be immutable because that makes it very easy to parallelize. That said, many of the Arrow implementation libraries, if they can be sure that they're holding the only copy of an Arrow array, they will potentially take advantage and modify in place sometimes, if the library implementation can be positive that there's no other areas pointing to the same Arrow array. Otherwise, you're right. That's where there's going to be effectively one copy. You're going to take the one you have, transform into the new spot.
Yeah, that sounds like what you want, essentially.
The vast majority of the time, that's what's going to happen. Yeah, the majority of the time in a lot of the computational libraries, it's going to be just taking what you have and then just modify into the new memory spot, which is what you want because it makes very good parallelization.
Yeah.
And also guarantees you're not going to break anything with concurrency issues. But one of the benefits, Arrow, you have most Arrow primitive arrays, you've got the data buffer itself, you've also got a nullability bitmap. And that makes it really nice for processing, because if you're doing an operation where a null value stays null no matter what, you can just take the null bitmap as is and then just only process the data buffer. And you're guaranteed the correct values because that null bitmap isn't going to change. Or another common processing when you're doing operations, say you're doing addition of 2 arrow arrays. You can, in parallel, process the null bitmaps and process the data buffers, because you know null plus null is null, or null plus whatever, or whatever plus null is null, which means you can perform a vectorized bitwise and on the bitmaps.
That saves a bit of time.
And then in parallel, add, the data buffers, benefit from the vectorization on both sides, rather than for each element having to check the null bit.
Yeah, I can see how that's helpful.
So there's, like I said, Arrow is intended to be highly performant for analytic use cases, in addition to all the benefits for transport.
Yeah, something interesting about kind of this whole zero copy thing, like where I've seen zero copy come up has been when I was reading like the Zero MQ book at one point, and there it was brought up like in the context of mostly high frequency trading and that kind of high performance computing. And there, the way you achieve it is by just piles of custom C++.
Yep.
And this seems like with enough adoption, everyone just gets zero copy, which is a wild perk of kind of establishing a standard. Usually establishing a standard just means you get interoperable libraries, but also lots of XML. And this is not that.
It's kind of the opposite.
Yeah, it is exactly the opposite. I mean,
no XML?
One of the things I always find interesting is that people find really, really interesting is most data services nowadays return JSON.
Yeah. Ooh. Airbyte. I'm looking at you.
Because it is human readable and everything can process JSON.
Yeah.
I'm looking at you, Presto, Trino, Druid. These column-oriented data systems where the only way to get your data out is JSON is ludicrous to me. Whereas then you could just return Arrow, which is already column-oriented. Half of these systems are using Arrow internally anyways, or they're using something that's very, very close to Arrow, say DuckDB and Meta's Velox, are both using effectively Arrow, but slightly different for their own purposes internally. But anyways, if they return Arrow data instead of JSON, you get all of those benefits. You're not paying that humongous cost to go from whatever they're doing internally to JSON text.
Yeah. And then parse that.
And the receiving side to convert back to something it can use from JSON.
Yep.
Like people don't realize that at scale, that's enormous.
Yeah.
Sure, for small data sets, not much of a difference. But for a large amount of data, it's huge.
Yeah.
Think about it. You have the JSON value 1, 2, 3, 4, 5. 12,345.
Mm-hmm.
In JSON, that's 5 bytes.
Yep.
Not to mention a 6th byte, the comma, the colon, the property value name, however many bytes there. Arrow, you could use a 32-bit integer, or you could use a 16-bit integer if you want, if it's small, if the whole data column is small enough. So 2 bytes, 4 bytes per value. You have enough rows, let's say 500,000 rows.
It makes a difference.
That's almost a couple. It's almost a couple meg right there for the one column, if not more.
Yeah, and that's just the one column.
Yeah. So like using Arrow instead of that's what we want to see. We want to see Arrow become that ubiquitous portion of this kind of modular, composable data systems.
Yeah. And to make that actually happen in a useful way, I've seen the tools that are being built inside of the Arrow project around the Arrow format, like Arrowflight RPC and Arrowflight SQL are interesting parts of that, where it's like, so Arrowflight RPC, I think a fair characterization is that it is a standard gRPC setup. Like a
better description is it's a framework. It's a framework. Arrowflight RPC is a framework for building RPC communications with gRPC centered around streams of Arrow data.
Yeah. And the interesting thing there is when I started looking around, like, okay, but what kind of data pipelines, data tools, data engines are out there that can kind of sling Arrow data efficiently?
Mm-hmm.
And it's like, that's a tricky question. But
and then you'd be surprised.
Yeah. But immediately I started also looking then for which ones use Arrowflight, and right now it's not really any, as far as I can see.
So Arrowflight on its own, there's just Dremio.
Okay, yeah.
But there's actually quite a bit that are using Arrowflight SQL.
Okay, yeah, that's something to look into.
Arrowflight SQL is essentially an implementation using the Arrowflight framework.
Yeah,
it is a defined standard protocol for interacting with a database interface centered around streams of Arrow data.
Yeah.
So Dremio obviously does support it, but in addition to Dremio, you've got InfluxDB supports it. There was an Arrowflight SQL plugin created for Grafana. So Grafana can use Arrowflight SQL to interact with data sources.
Nice. Yeah. Yeah. So what I see when I look at like Arrowflight RPC is that it feels like you want that to be used for like Kafka and that type of thing, where in many cases like Pulsar, and I guess Red Panda is just another Kafka, but Nat's Jetstream, like there are a bunch of these kind of persistent queue type of dealios, streams. It's all about passing streams of events, and that's very often a big part of how people pass data around for processing. And it really started to annoy me as I looked at, like, I would want these to speak Arrowflight RPC. Why don't they? Because then it would be Arrow into the thing. It holds on to it for as long as necessary, or whatever your policy is, and you can pull Arrow from it. It never needs to look at the data. It doesn't need to do anything clever with the data. And the only copies would be at the point where you send it across the network. And there's a immense potential for elegance there. It's like,
because Arrow also supports hierarchical and nested data types. Like anything you could represent in JSON, you can probably represent in Arrow. one of my favorite examples to use with this is OpenTelemetry recently introduced an Arrow-based version of their protocol.
Interesting.
So, like OpenTelemetry, there was a bunch of work around there. One of the primary guys, Lauren Carell, who was developing the proposal for it, reached out to me on LinkedIn for advice and to help kind of work out the protocol and the proposal there, how best to leverage Arrow to represent it, because there are slight limitations, like you can't really represent a recursive structure in Arrow because the schema Arrow schemas don't really represent recursive structures well. But he put together this proposal for representing OpenTelemetry's like tracing data that passes from the collectors using Arrow. And Arrow's IPC format, which is essentially just a small flat buffer metadata followed by the raw data buffers of the arrays, just as is, which is one of the things that makes it very efficient. And the IPC protocol also allows for compression if you want to, because then you're dropping some of the zero copy in exchange for the compression to benefit network transmission, but depending on your scenario, one or the other might be best. But anyways, using the compression and using the IPC format with the Arrow IPC representing from telemetry, he was able to show like 40% performance gains or better in some cases on OpenTelemetry data, which the problem you're running into nowadays with OpenTelemetry data is that, one, before this, it's primarily JSON, and two, it's highly latency sensitive, and three, we have so much telemetry data nowadays.
Yep.
It's becoming enormous. And therefore, you're hitting these problems of trying to hit those latency goals.
Because you have so many curly brackets you need to store.
Yeah.
Exactly. So by using Arrow as a representation of the data, you save no serialization cost to get it into JSON because Arrow is just Arrow. No deserialization on the other end. It's enormously smaller to send it across the network, binary protocol and all that.
Yeah.
And then he's also working on furthering the processing into the actual OpenTelemetry processors to just, like right now, the first step was using Arrow as the format for the transport. The next step is actually having the collectors and the processors do the actual processing of the data on Arrow directly. Yeah. The drawback there is that you'd have to make sure you're using the newer, like, OpenTelemetry processors and collectors to leverage it for those, which is why the first step was just make the collector work to pass the data transport so that you don't have to like upgrade everything, the whole pipeline. But that's going to push it down. And then you get all those performance benefits and all that improvement. And Arrow is one of those things where, yeah, it's infectious because it's best. It works the best when you use Arrow through the whole system. That's why we have things like ADBC, Arrow Database Connectivity. If you're familiar with ODBC, JDBC, the idea is the same. A single interface, single API that is defined as a C API, that anything that can interact with a C API can interact with it. And then you have drivers. The drivers implement that API, then you interact with the API to communicate with the drivers, to interact with whatever database you want. Only in the case of Arrow, ADBC, it's Arrow-oriented, Arrow-native. You get data in Arrow as Arrow record batches, Arrow streams, which means that you're able to have your application side interact with Arrow data no matter what with ADBC. And then the drivers can handle any conversion necessary, or if the underlying data source can return arrow, then you can just get arrow straight through. You know, we at Voltron Data, we worked with Snowflake and created a Snowflake ADBC driver. Because Snowflake, what is little known, does return arrow data directly if you want it
to. And I think that's like the ADBC is a super pragmatic example, because it might not be the end game where you want everything to be, because like most, for example, talking to SQLite or Postgres, like they don't do arrow natively, so it's not the optimal path.
And yet there is a Postgres ADBC driver.
There's always,
which is as performant or more performant than just grabbing it from Postgres directly.
So that driver, is that with an extension then?
It's part of the ADBC project. There's two pieces to it. There's the ADBC driver for Postgres, which is actually in many cases using the Postgres binary protocol directly.
Yep.
There is also an Arrow Flight SQL extension for Postgres.
Yeah, that's what I figured, because then you can get very close to the database. Yeah.
So there is also an official Arrow Flight SQL Postgres extension.
Yeah, and I think that's a kind of a cool approach, because you will always need to be dealing with like Postgres's and MySQLs and everything. So having a strategy there.
The application side only have to write one interface.
Yeah. So you might end up with a pipeline that's starting with ADBC, and then it's like Arrow and a bunch of Arrow flights, fanning out, fanning in, doing a bunch of processing, distributing across clusters and doing all the pipeline stuff, and then ends up in a few different SQL databases again, which means ADBC again. But in between, in all those processing steps, you can get very, very efficient.
Yep. I mean, there's been, so far we've heard announcements from DBT said that they're looking at adopting ADBC.
Yeah, that would make sense. So for the listener who doesn't know what DBT is, this is something that made me both upset when I realized, and I've since been convinced that it's probably also quite useful. But this is what people call SQL to SQL. Which is, so you write SQL with Jinja templates from Python.
Oh, yeah. I think I remember you mentioning this.
Yeah, to pull data from a SQL capable store. So very often it's like BigQuery, but it might be BigQuery, it might be Postgres, it doesn't care. And then you shove it into another or the same store using by essentially just writing SQL. And this is something data people like to do that I think many software developers might frown at, and that might be my reaction.
I mean, ultimately, DBT is it's a workflow.
Yeah,
it's just a workflow organizational thing.
Yeah,
scheduler and stuff.
And if you worked with Python, like I get a bit of an itch when I'm thinking about like it can't be that efficient unless they've done some very freaky stuff. But then I looked around on like the Arrow project site, and it's like, I bet they could replace DBT with Data Engine or Data Fusion, is it?
Well, that's the thing. Data. So DBT is the workflow scheduler, organizational side of things. Data Fusion is a compute engine.
Yeah, but they don't use Data Fusion today, right?
DBT, I have no idea.
Yeah, no, I think they just do. They just ship Python data structures around, I imagine. But
probably, yeah. I mean, Data Fusion itself is a compute engine written in Rust. It does have an orchestrator and scheduler Ballista. And Data Fusion is currently in the process of becoming a top-level Apache project in and of its own right.
Oh, it's breaking out from Arrow.
It's breaking out from being an Arrow sub-project to become its own top-level project, which is exciting. It's good.
Yeah.
But another thing is we're also seeing one of the bigger contributors to ADBC right now, outside of the general Arrow community itself, has been Microsoft.
Oh yeah.
Cool.
We've been seeing there's a couple of Microsoft employees that are some of the largest contributors to the ADBC repository right now.
Wow.
They seem to be really, really fond of it. They've been contributing a very large C# implementation of ADBC.
Cool.
So, I'm looking forward to seeing, ADBC become bigger in use by Microsoft. Hell, if we're really lucky, maybe Power BI will support ADBC.
Yeah, that would be something. Yeah, but it's been interesting to see and try to get a grasp of all the bits that make up the Arrow project, because there are some things that are very central to the Arrow project. It's like the Arrow format and Arrow flight and ADBC. That feels like kind of a core central piece. But then there's stuff like IBIS that's more on the Python end of things, and then finding data fusion in there.
So for anyone who's not familiar with IBIS, IBIS was also created by the same Wes McKinney as Pandas and PyArrow and Arrow. But IBIS is best described as essentially abstraction for your SQL. It provides a Pythonic API, a data frame style Pythonic API, and it effectively generates SQL for your backends. So you can write Python using IBIS and then swap out the backend to whatever your underlying data compute stuff is without having to change the Python code.
Which also seems like a DBT oriented thing.
It is very, very useful for DBT and others. Yeah. I think IBIS last I heard had like 20 something backends right now.
Whoa. That's a lot.
Like whether you're going like Snowflake, Dremio, Spark, Pandas, Data Fusion, BigQuery, SQLite. There's like so many backends. But the idea is basically being able to make it so that you can write the Python code to interact with your compute engine and do your data manipulation once. And if you end up having to change out your underlying engine, you don't need to do a rewrite.
Yeah, that comes in handy.
You don't if you have to move from Snowflake to BigQuery, if your code is written using IBIS, you don't need to rewrite all your SQL.
That's useful. That's deeply useful.
And that is the point of IBIS there.
Yeah, and it also means if you're dealing with a bunch of different stores, which seems pretty common in this case, like that's kind of what DBT is for, like talking to a bunch of different stores. I don't think it abstracts the SQL though, because then I think you're writing a number of different dialects. So.
Yeah, and IBIS gives you the Pythonic interface to abstract away the underlying SQL. So you write, like chained method calls like you would do like Python.
Yeah.
And then it creates the appropriate SQL for the underlying backstore.
Yeah.
Which is a lot of fun and very, very, very useful. And we're seeing IBIS get adopted by lots of places for exactly those reasons.
Yeah. And to unpack data fusion a little bit, because I think that's something that will definitely interest people. So it's built in Rust, and if I understand it correctly, it's essentially if you have a bunch of Arrow data, it uses Arrow data internally, and you can shove SQL at it, and it will answer your questions.
It's a SQL engine.
Yeah.
It's just plain and forward. It's a SQL compute engine. It is similar to DuckDB. It's an embedded SQL and it's an embedded SQL compute engine.
But with all the upside of Arrow, if you're doing Arrow upstream or downstream from it.
Yep. I mean, I will say that DuckDB itself, its internal representation is effectively Arrow. And DuckDB does expose Arrow interfaces via the Arrow C zero copy communication. And DuckDB does implement ADBC. So you can get DuckDB, ADBC straight through. The DuckDB library itself is its own ADBC driver.
Yeah, it just provides it.
Yeah, it provides the external ADBC interface right in the DuckDB libDuckDB.
Oh, that's very nice of it. And then we have Substrate that comes up when we're talking about your... I'm not sure, is that under Arrow or is that kind of separate?
It's separate. Substrate is separate, although there's a lot of work together. There's a lot of communication together. There's a lot of collaboration there. Substrate, for those who aren't familiar, essentially it's an intermediate representation for SQL. It's the best way to describe it. Think about the idea of separating the so if you're familiar with, say, how a SQL engine might work, you shove SQL at it, it's going to parse the SQL, it's going to generate a logical and then a physical plan to actually execute SQL. Substrate is a way to represent that plan. So you can take your SQL, parse it, and generate Substrate, which allows you to completely separate your parser interface from the compute engine side of things.
Oh, yeah. So then you can switch things out again behind the back of people.
Well, it enables modularity, composability, but also if you can develop optimizers that run against Substrate,
they can optimize anything that uses Substrate. This is such a very Arrow approach to a different thing.
It's exactly what it is. So, but it also means that if you write tools that process and say you want to generate, a visual plan, well, either you can write something that will visualize for every single SQL dialect that exists,
or you parse it once to Substrate,
or you can write a tool that creates a visual plan from Substrate, and anything that can parse and generate Substrate will work with it, and you create that separation between your interface and your engine. And then imagine the idea of, say, you go to Calcite, you throw SQL at Calcite, you generate your Substrate plan. Then you throw the Substrate plan at insert your desired compute engine here.
And we're done.
And now you've created this situation where whoever parsed it doesn't have to be who executes it, and vice versa. Hell, you don't even necessarily need to use SQL anymore at that point. You could create an entirely different interface. Maybe you want to make lots of data people scream and use GraphQL.
Yeah, why not?
And then generate Substrate from GraphQL. This is an idea I had a long time ago. But then you can just use the same compute engine regardless, because the engine can compute Substrate. And you get this unified, intermediate representation.
Yeah.
And we're seeing this compatibility happen. Meta's Velox engine, DuckDB support. DuckDB can generate Substrate plans from its optimizers. Meta's Velox engine can execute Substrate. Arrow's C++ library has Acero, which is a reference implementation of the compute engine that uses Arrow. It generates and executes substrate. And Arrowflight SQL has interface methods, and so does ADBC, to accept substrate plans.
Yeah, so you don't have to ship a bunch of select statements over the wire. Again, getting away from strings. It's like you don't like them.
Either ship the SQL string, or you can throw the actual substrate plan directly. And the more things that use substrate, then you get more of these utilities, more of these tools, more of these things that can be focused on substrate that can then become more universal and more composable and modular and all those great things that you really want out of a data system.
Yeah.
And it's an interesting thing, just the idea that, like, okay, yeah, we write the SQL, but we might as well, like, we could turn it into an execution plan at compile time if we like. For certain cases, that might be appropriate. And for certain cases, it's almost definitely not.
Yeah.
But,
yeah. And by that point, then you can programmatically generate substrate plans.
Yeah. And you can keep them around and apply them over and over again, depending on what you're doing. Mm-hmm. Because, like, the SQL string is for people.
Yep. I mean, prepared statements in a lot of in some systems will take your SQL, will generate the plan, and will keep the plan around for every time you execute the prepared statement.
Yeah.
What a lot of systems will do. You can do the same thing with substrate. Yeah. But it also gives you that interoperability part. Because because then you could say, take a substrate plan and distribute it.
Yeah.
Distribute chunks and pieces and parallel parts of the substrate plan to different nodes that could be entirely separate engines, optimized for whatever operation you're doing. And it'll all work because it accepts the substrate. You can pass the substrate around, you get the right output, the right input, but the plan just works against all these different engines. Yeah. That's the goal.
Has anyone explored, like, compiling substrate for GPU processing? I imagine that's kind of something people are thinking about.
Well, so that's a lovely segue. Great segue. I like it. One of the things that the Arrow libraries and stuff are doing. For reference, I'm on the Arrow PMC. I didn't say that earlier.
Yeah, it was my fault. Frederick is usually very good about introducing guests, and I've been here so many times at this point.
Yeah, you just said my name and really didn't do much in the way of introduction.
Yeah. So I'm rude, he's polite, and I'm a frequent guest, so I don't need introductions.
So belated introduction. Matt Topol. I work at Voltron Data. My day job is I work on the Arrow libraries. That's what I do. I wrote the only current book on Arrow that exists. I'm actually currently working on the second edition of that book because Arrow moves quickly. And that book was published at this point. Hey, Happy New Year. 2 years ago, that book was published. June 2022.
This is going to be yearly editions.
I can't do yearly editions because I don't have the time. But, bi-yearly, we'll go with that. Sure. But, we've added new data types and things like that. But anyways, so there. Short, quick introduction. Yay. Anyways, so back to the GPU stuff. So the Arrow library, the Arrow C++ library currently has a bunch of abstractions for interoperating with Arrow and GPU data. This is important because, there's the NVIDIA Rapids library, cuDF, and so on. If you are familiar or maybe not familiar with those, essentially, Rapids and cuDF are Arrow on a GPU. That's literally what it is. The memory representation for cuDF and Rapids is Arrow, just in GPU memory. And so we're creating abstractions in the Arrow libraries to benefit and leverage the Arrow data on the GPUs. There are extensions in substrate that are being developed, being looked at to, identify what device to run things on for that reason. And then building on that, I get to have my lovely segue now into Voltron data. Recently, I wasn't able to say this when I was at the conference with you guys, but recently, Voltron data did go public with its actual product, which is the Theseus compute engine, which is an accelerator native distributed compute engine that utilizes Arrow under the hood and Arrow interfaces and protocols and all that fun stuff. Arrow Flight, Flight SQL, IBIS, everything we talked about. You can leverage with Theseus, accelerator native compute engine.
I must say, when I saw that pop up on LinkedIn, I was deep into this hole of just digging into Arrow stuff, and I don't think I've ever been so vaguely excited about seeing like a proprietary enterprise oriented data platform or otherwise like proprietary enterprise platform at all being released. But I'm like, yeah, okay, cool, they're doing the thing.
Exactly, yeah. We back in November at HPE had a conference, and that's when we made a big announcement through a partnership with HPE. Their cloud compute platform, Ephemeral, is like the open, the open spot into using Theseus from the start, and obviously people can reach out to Voltron directly if they want, and check out Voltron's site. But it is what it says on the tin, accelerator native. It's going to run on whatever hardware you throw at it. And the idea behind Theseus and the idea behind wanting to leverage the GPUs and the hardware accelerators is you have all this compute and all this stuff going for AI and ML. And those are going to run on GPUs, right? Which means that they're going to run super fast because you're throwing GPUs at them. The problem is that all of the things that feed the data to your AI and machine learning processes are currently running on CPUs.
Yeah.
And we have enormous amounts of data. Which means
Jason.
We can't feed the data fast enough to utilize the hardware that we're using for the AI and the ML. And that's the goal of Theseus. Yeah, the just general purpose compute, but accelerator native in a distributed fashion so that you can feed the data just as fast as those AI and ML systems can consume it. Because eventually we're going to hit a wall.
Yeah.
Where it's just physically not possible to feed the data fast enough on CPUs. And even now we're hitting that wall where, data like AI and ML operators are like happy if they can get 20-30% utilization on their GPUs because getting enough data through it.
Even if you're incredibly skeptical about like big data and all this data wrangling, and even if you're horrified by ML and AI, I don't think anyone really wants all this expensive hardware to be underutilized, because that just means people put more of it out there. It's like the inefficiency is horrifying regardless, and it's in the big and in the small. Like I can see wins with this type of end-to-end. Like the whole thing is Arrow benefits immensely from being end-to-end, or that's at least my read of it. And
that is exactly what it is.
You can still have gains as long as you use it in like the compute heavy end of things, but you benefit more from having it end-to-end or as soon as possible in the pipeline. I could see just companies that want something to be low latency, just maintain a low latency stream processing, So stream processing is a thing in data pipelines, data engineering, and there's a surprising amount of JSON involved.
Yeah,
Or other formats, many other formats usually.
The thing to remember that I have to stress and remember is, for small amounts of data, you're going to get very little benefit to convert to Arrow just to transport it, and then convert out for your system if your system isn't already processing Arrow. If it's not a large amount of data, there's not a huge benefit to that unless you're using Arrow the whole way through the system. For large amounts of data, then you'll see bigger benefits even if you're not passing Arrow through the whole system. I want to say that because I want to point out that Arrow in itself is not a magic bullet. Okay, if you're only sending small messages of data, and you're primarily operating in a row-oriented fashion, then Arrow is not going to buy you much in and of itself. And I don't want people to, spend a bunch of time, use Arrow, and go, "Hey, this didn't help at all." Like, well, it's still use case based. If you're row-oriented primarily, if you're transactional, if you're row transactional, and you're not throwing large volumes of data, then you're not going to get much of a benefit just by switching to Arrow. People will ask about the cases, when does it make sense to use Arrow? The question is more, given the current landscape, it's more frequently the question should be, when should you not use Arrow than when you should use Arrow. The current landscape of data, most times Arrow is going to be the right choice if you're building a new system.
Yeah, and I think it's an interesting thing. Like, if you're doing, for example, stream processing at a fairly low scale, but you're calculating like ongoing windows on data and stuff, then you're doing some column-oriented workloads in there, which immediately gives you some efficiency, and which is really inefficient to do with, for example, JSON, and you get all this serialization and deserialization.
Like stream processing is a good example of, if you're not going to throw Arrow through, threading it through the whole system, you're probably not going to get a huge benefit by just switching the communication to Arrow.
Yeah.
Because you're not sending, in most stream processing, you're not sending large amounts of data on each message.
Yeah, no, you're essentially using it very similarly to how you'd use JSON or something row-oriented.
Exactly. And if you're only doing it for the communication, in that scenario, it's not going to be that beneficial because you're still going to have to convert it to and from Arrow from whatever you are using internally.
But odds are also that it won't necessarily be detrimental either.
Correct. That it's not necessarily going to be detrimental. It's just not going to give you a huge benefit. But if you thread Arrow through the whole system so that your processing is using Arrow the whole way through, so that you're not converting to and from it, you're just sending bytes around and benefiting from not having to serialize, deserialize, then you'll start seeing benefits. But again, on a small scale, it may or may not be worth it in that scenario.
Depending on how complex it is for you to get there.
Exactly. For large amounts of data, you're going to see a significant improvement. Like we've seen, going from JSON to Arrow, we've seen 20x improvements. We've seen the size of messages get 20 times smaller going from JSON to Arrow if you have enough data. It's one of those things where you get benefits at scale. You can still benefit without scale, but it's going to be very small unless you're threading it through the whole system. Like Lars was saying, Arrow, you're going to get the best benefit out of Arrow by it being used throughout the whole system. One of my favorite things I said at my previous company was being able to take Arrow data all the way to the front end. Because you got Arrow JS, you have Arrow JavaScript and TypeScript libraries. So your back end compute stuff spins Arrow. Your services return Arrow. Doesn't have to be Arrow Flight. It could just be HTTP. Just streams of Arrow blobs. Works perfectly. Arrow IPC.
Oh, it would have so much smaller messages.
You throw that to the front end, and now you have your JavaScript, TypeScript library takes the Arrow data, and now you have Arrow the whole way through. And that means that every step of the way, every system you pass through, you've just saved a serialized, deserialized cost. In addition to the bandwidth benefits of a binary format.
And I will say there's, of course, like, especially for example, front-end work, there will be disadvantages, especially until tooling catches up with losing the human readability.
Yes.
But with enough JSON, that goes away.
That didn't sound that positive, did it?
Yeah. No, I find this kind of end-to-end idea compelling. And something I was surprised by when I looked at the Voltron site was the composable codex, which is kind of essentially philosophical writings underpinning, or a pitch deck. It's a very long pitch deck if it's a pitch deck, but it's essentially a combination of a book and presentation slides, which sort of outlines the bigger ideas and first starts with kind of these are the problems in data. These are the real problems that we see. Yeah.
You'll notice, like, I was threading the modular and composable throughout what I was saying. That's
and
exactly
I think the chapter that I've linked around the most is probably also the one that hits on Arrow the most, but that's the standards bit where it's
standards over silos.
Yeah. And just that, like, the standard has to be good enough, or a standard is not necessarily a big win. But generally, having a agreed upon standard is a win in and of itself. In the case of like Arrow and Substrate, getting that standard right, it becomes very, very important, because they are all about performance. And it's like, if Substrate is kind of screwed up, everything that builds on Substrate inherits that screwiness.
Yep, and that is exactly where we're at here. Is there? I mean, there's large amounts of people that are contributing to these projects, that are part of the projects, that are working at it from lots of different angles. You know, I mean, the Arrow project has been around. We've got over 900 unique GitHub contributors to the project.
That's cool.
Wow.
You know, there. Last I checked, we were at like a bit over 12,500 GitHub stars on the Arrow repo. The main. I'm just talking about the main Arrow repo.
Yeah.
I'm not even talking about the offshoot things, AWC repo and all those. I'm not even talking about those. It's the main Arrow mono repo with the majority of the implementations in it. You know, last I checked in November, PyArrow, the Python Arrow implementation, had like 88 million downloads in just November from PyPy.
It's not bad. Not bad.
In just November. So, like, you know, it is a good thing to point out that if you do look into and adopt Arrow, you're not, you know, it's not vaporware. You know, this is something that a lot of people are heavily invested in. The project moves quickly. There is a lot of ongoing activity and development and popularity with this project. Compared to a lot of Apache projects, it's relatively young. But you're not like, but it's something that is actively developed and actively worked on with a very active community. You know, you're not, you know, a lot of times when people look at open source projects, there's the concern of adopting something that's just going to die.
Yeah.
or
Yeah.
adopting something that's going to go away or whatever, or isn't well enough supported. And that's the thing to keep in mind here is that Arrow is not going to go anywhere anytime soon. People are building things on Arrow. DuckDB has ADBC built right in there, and we're leveraging Arrow internally effectively. Meta's Velox, Voltron's working together with DuckDB and Meta and adopting Arrow standards. Dremio's entire internal representation is Arrow.
Wow.
Dremio actually is the one who pioneered the Arrow Flight protocol in the first place. Arrow Flight SQL. So we are adapting to the needs. There are new data types that were added to Arrow relatively recently based on internal format representations that Velox and DuckDB use, which are themselves based on research out of the Technical University of Munich. What we refer to as the quote unquote German style strings.
That's a new one.
Well, because it was the Germans who came up.
Yeah, of course.
It takes advantage of short string optimizations and the string view type.
Doesn't
setups.
seem realistic that the Germans would be contributing things that relate to short strings.
I know, but it does seem realistic as efficiency.
Yeah, that's true.
Grudgingly. Yeah.
But so we are adopting and adapting to the changing ecosystem and the changing landscape of systems to make sure that Arrow stays relevant and performant and efficient. Arrow's got run-end encoded data sets now. You can represent run-end encoding with Arrow. You can represent these list views and string views and take advantage of short string optimizations with Arrow, and so on and so forth. So it's not going to die anytime soon. So we really are trying to increase that adoption, and it is increasing. We're seeing wider and larger adoption. Arrow as a in-memory representation pairs very, very well with a lot of the column-oriented file storage. Like Parquet and Iceberg. Well, Iceberg's a table, metadata, like Parquet and Orc and things like that. Because those will quickly, efficiently, and sometimes zero copy transform from those on-disk formats to in-memory Arrow. Arrow also lends itself very well to M mapping, which allows you to really process and deal with larger than memory data sets.
Oh yeah, I want that. Yeah.
Very efficiently. We haven't talked about that much yet.
There's always more.
Yeah, that seemed like it was perhaps a larger part of the Arrow idea earlier on. I think there was some cutesy name for a file format, Quill. Yeah.
Feather. Which the Feather format still exists. The Feather format's basically just
you just write it to disk. Which is sweet. Saves a bit on the ingest step there. You just grab it off disk.
Yeah, and the Arrow IPC Feather format is memory mappable. Hugging Face data sets. That's what it is.
Oh.
Hugging Face. Their data sets that they provide are Arrow because it enables them to cache and mmap enormous data sets with very little memory usage. You can process, a 50 gig data set to process one column of it and only use a couple hundred meg of memory.
That's nice. It's nice. That's not the system I'm working with today.
because of memory mapping. So things like that. And you can do that because the Arrow format data is identical in memory as it is on the wire or in the IPC format or whatever. So there's no conversion or serialization, deserialization. You can just reference the bytes as they are.
I wonder how many so-called big data systems would turn into like single machine data systems.
Oh yeah,
by simply boiling down to Arrow and just like, maybe we can just keep this one machine, because honestly, it was all about curly brackets and CSV files.
The machine is actually Lars's phone. Don't tell anyone.
That'd be interesting.
Yeah, but it's been so much like talk about, well, you have all these data lakes and data warehouses and data lake houses as well. And like some of that architecture is absolutely useful and necessary for certain workloads. But there was a period of hype when it was just like everyone needs big data, and most companies did not have big or data. So they started getting into data, but they were convinced it was big. Yeah.
I mean, that's still true.
And now people absolutely want to get into machine learning and AI, and I think that's when it's good to at least be aware that there are formats for this that are kind of a bit more forward-looking than... So if you pick up kind of the default tooling for building a data pipeline today, you will not get Arrow end-to-end, and that's a little bit disappointing. Once you know.
Well, I mean, but if you think about some of the default tooling gives you Arrow in some pieces, though, like polars and pandas.
Yeah. I'm thinking like, how do you pull data from systems? It's like Airbyte and Fivetran, and there's a lot of JSON going on.
Yep. I mean, I would love to see Airbyte and Fivetran. I would love to see them adopt ADBC. I was at a conference a while back, and I was talking with some guys from Apache Hop, and which is another orchestration data, scheduling data thing, and they seemed pretty interested in looking into ADBC. And I don't know if anything came of that, but I would love to see that get adopted there too. It's one of those. It's just one of those things. I think that what's going to happen is we're going to see one or more of them are going to eventually adopt ADBC publicly and be all open about it, and it's going to be awesome. And then we're going to see more and more quickly jump to follow that as it happens. Like it's going to be one of those like watershed, like something popular is going to do it, and then everyone's going to follow. And that's my theory on it. So I would
love to see like a data orchestration, like well, all of these platforms end up like, you design your directed acyclic graphs and you tell things, and then it does some calculations to figure out how to distribute all the workloads and yada yada yadas, and then it passes a bunch of data around. And to me, it seems like the natural next step with Arrow in existence is that would be Arrowflight RPC. That is the normal way of distributing work between these like DAG stages, essentially.
I mean, one of the cool things. So the thing about like Arrowflight RPC, like I said, it's a framework, because Arrowflight RPC does not specify the actual messages outside of streams of Arrow data for the results. That's why Arrowflight SQL is built on top of it. Arrowflight RPC is more something you would use internal to a system between nodes that way, and you would use that to pass data around, like
to build your new Apache Spark, essentially, and
or build your Theseus.
Or build your Theseus. Theseus open source when?
Not my call, not my department. I stay the hell away from that. That's not me.
Understood.
I work on Arrow directly and help provide anything that they need if they need, Arrow stuff. Actually, one of the exciting things that I'm currently working on is being able to pass non-CPU data across Arrow, Flight, RPC, and other protocols.
So passing data that is currently inside of a GPU, essentially.
Like leveraging things like UCX.
Okay. Yeah, I'm not familiar enough with how that stuff works.
UCX is similar to things like libfabric or things like that, where you have this. It's a protocol. It's a collection of libraries for transport protocol communications. For find the fastest route to send this data between these spots. Like if this data is currently on the GPU here, and I want to put it on the GPU over there, and there is, InfiniBand between them, then it'll use it. If it can do remote memory accesses, it'll do that, RDMA. Like UCX is a wrapping library for doing a lot of those operations without having to be as, direct or knowledgeable about it. You can pull things off and do shared memory and improvements in those directions. And so I'm looking at and I'm working on developing essentially a protocol, for transporting data across these shared memory setups and be able to pass shared memory or non-CPU memory that's Arrow data across these communications. So like if you're on the same node and have access to the same device, then you can just reference the shared memory as is. And if you're not on the same device, then you can use RDMA remote direct memory access to grab the memory that way and leverage the shared memory and things like that.
Oh yeah, I did start reading about UCX, and I could make heads or tails if whether this was something I could use, because like the Arrow end of it, like that documentation is fine. Like it's just like, oh, use the UCX, and then I started looking at UCX on GitHub, and I'm like, I don't know what this is. This is some high performance compute people that have put something together that I don't understand.
That is exactly what it is. So I'm working with, people who know far more about it than I do, and just trying to come up with and create like a reference implementation idea to prove that it works to communicate Arrow data across these setups. A while back, Arrow. So Arrow, like I mentioned, Arrow has the zero copy, the C API zero copy communication that just passes pointers with some structs. A while back, I enhanced that and added the Arrow device array, so that within a single process, within the same process across different runtimes, you could pass non-CPU data. And I created I made a little proof of concept of doing something where I made a little Python script, which utilized the NUMA CUDA library to allocate some GPU data and perform some CUDA JIT operations on it, and then take that and passed it to a compiled C++ shared object that utilized NVIDIA Rapids, operated on the GPU memory, and returned the memory, and then performed another operation on the Python side on the GPU memory, and then got the result. And what's cool about that is, traditionally, to do this, you have to do a whole bunch of copy the data from the GPU to the host, pass it across the library boundary, then copy it back to the device, so on and so forth. But with the Arrow device arrays, I kept the data on the GPU the whole time, despite crossing the Python C++ boundaries. I passed device pointers and some metadata, and it just worked.
Magic.
because and so I'm going from like different CUDA libraries and working on this data, operating on it without the data having to copy to and from the GPU.
I think easier to do is probably, so I know the gRPC thing has Unix domain sockets. I don't know if that's zero copy, but like local, I guess IPC, like there are mechanisms for passing memory between processes and all that.
Yep.
So that's also something you could gain. Like a smart data orchestration engine could do some very basic optimizations. It's like, yeah, okay, this is a small scale, almost silly level of data system. Okay, yeah, let's just run a few processes locally on the same machine, and they can share some memory around when they need to, instead of passing it over a fake network or a local network, which is silly and causes copies. So yeah, okay, we could do it that way, and then it's like, okay, now we need to be dealing with this as a distributed systems, more nodes, yada yada yada. Okay, but we already have facilities for that, and then of course we have the very extreme case that I don't think I've ever met anyone who works with the type of thing that needs Theseus, but it's certainly out there.
Anything operating at, say, petabyte scale data, or terabyte scale data, if you need to perform an operation on 10 terabytes of data, which is frequent for AI pre-processing, Theseus is helpful there, because it's going to do it massively faster and cheaper for you than Spark. For example, it's just. That's where the benefit is. That's the plan. That's the benefit.
And I imagine GPU models are not just used for training LLMs and all of that. Like so much of it's like forecasting, and like fintech, I imagine, has plenty of models trained that they just want to keep well fed.
That's exactly the case.
Yes, there's a lot to think about in here.
We also need a brief candy review before we wrap up. How did the candy land?
Candy.
We had Matt go through some of traditional Swedish lösviktsgodis.
Oh, yes.
Let's see here. The biggest hit was the foam bananas.
Foam bananas, okay. Skumbanan went well.
We want more of those. Like, why is that not available in the U.S.?
That's upsetting.
The salty outside one, but the surprise in the center candy. I forgot what that one was called. The thing with the terrifying surprise inside.
Oh yeah, Turkish pepper, perhaps the hard ones.
It was the hard candy with like the thing, the thing in the center of it. That was like that thing.
Yeah, that was the Turkish pepper, I think.
That went over. That went over hilariously.
I bet. We're so sorry.
I had fun watching.
Yeah.
Like you guys had fun watching me.
Yeah.
I mean, so they weren't fans of licorice in general, so I didn't get to have that fun with them.
Couldn't convince them.
No.
They enjoyed the sour candies.
They should.
And I mean, and the general chocolates were really really nice.
Good stuff.
And they also really liked the Cloetta, the Turkish spice chocolate with the little chocolate ball with the cream inside thing.
Oh yeah.
They came in like so many different flavors, but
I think it was Plop, perhaps.
Plop,
that one.
probably.
Yes. That one.
Yeah, I remember they had a bunch of different flavors of that one.
Yeah.
Yeah.
They also really liked the hard candy in the red and white striped
Yeah.
wrapper. That was like a like almost like mint, but
Yeah, with chocolate
Marianne.
inside.
yes,
Yes. Yeah, that's a good one.
they like that one too.
Yeah. I missed that one right now.
It was interesting. It's all these like these are all like things that they're just completely foreign to us, which is great.
yeah, exactly. So, someone posted me a picture of a classic assortment box of chocolates for somewhere from some brand in the US, and every piece looked unfamiliar but good. So I was like, why isn't there more like cross-exporting here? This is upsetting.
Yeah. Although your guys' chocolate is a hell of a lot better than US chocolate.
I have not been impressed with the chocolate I've seen. Well, I haven't been impressed with the traditional American like chocolates. I think there's plenty of good fancy chocolates probably, but maybe those are imported. But
the fancy chocolates are important.
All right.
Yeah, I guess that's a good point to end on. Thank you so much, Matt, for coming on. This was extremely interesting.
I'd be happy to come back anytime.
Yeah, and for people like me who have a lot of reading to do now, there will be plenty of links in the show notes as well. So.
Yes, please reach out.
Yeah.
One of my big goals here is I want to get more people using Arrow and doing fun stuff and contributing.
Yeah, and I'll try to find some links for the candy as well.
Yes.
It's nice when like doing outreach and promoting your thing is actually essentially just a general good. It's like, no, we're trying to remove inefficiency. Yeah. It's just removing inefficiency where it's as plentiful, and it's not like, oh, you're trying to beat this other format. Well, yes, maybe JSON, but no one is really fighting for JSON.
Nope.
It's not like Apache JSON is over there just
shaking their fists.
He's on another podcast again.
It's one of my favorite aspects of the fact that I get to do my favorite thing of I get paid to work on open source.
Yeah, that's awesome.
It's one of the things I love about it. It's great.
Yeah, it's fantastic. Well, yeah, thanks again. Let's.
Thank you very much.
Tusen tack för att du lyssnar på Kodsnack. Vill du stödja oss? Tipsa en bekant om podden eller lämna en recension i till exempel iTunes. Du kan också köpa prylar med Kodsnacktryck eller stödja oss med en kaffe på coffee.com. Alla länkar och alla avsnitt finns på kodsnack.se.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.